recap of probability, what all you need to remember. The first one is have mutually exclusive event. Mutually exclusive events means it cannot happen at the same time. So if whenever they give you a question on two events, you have to see whether it is a mutually exclusive event or not. So if it is a mutually exclusive event, then P of A or B will be equal to P of A plus P of B. Okay, and P of the A or B means it is P of A union B, that will be equal to P of A plus P of B. And remember, the Venn diagram for mutually exclusive events will be two circles like this which are not touching each other. Okay, and if it is a non-mutually exclusive event, P of A or B will be equal to P of A plus P of B minus P of A and B. So this can be understood by this looking at this Venn diagram, which is not non-mutually exclusive events. They will have an overlap. So we are trying to remove the overlap portion because it will be added twice. So we are trying to remove it. So this formula is P of A union B is equal to, the total is equal to P of A plus P of B minus P of A intersection B. Okay, and now after this, the next one which you need to remember is independent events. Okay, so for independent events, it does not affect each other. The occurrence of one event will not affect the occurrence of the other. So in this case, it is P of A and B. Remember, in the previous one, it was P A or B. So here it is P of A and B, and that is equal to P of A times P of B. Okay, again in set notation, you can say that P of A intersection B is equal to P of A times P of B. And this is a common question what they ask in Living Cert. They will ask to show that the events are independent. So this is a condition for independence. So what you will do is like you will find the probability of A intersection B, and then you will find the probability of A and then the probability of B, and then you show whether the left hand side is equal to right hand side. So remember this formula, okay? P of A intersection B is equal to P of A times P of B. This is the condition for independent events. That is why I have mentioned it. Now comes the conditional probability, which is like P of A given B. So when they write it like this B is already happened. So what this means is like the probability of event A given B has already happened. So how do we find the probability of that? It is like P of A intersection B is equal to P of B. Okay. Now comes the permutation and combination. So permutation, the keyword is arrangement. So if they're asking you to arrange certain things, that is when we go with permutation, that is like NPR. Here the order matters. Okay. And when it comes to combination, it is selection. So if they ask you to select, the keywords are select and choose, those are all keywords for combination. So that is how we distinguish it. So here we are trying to arrange different things, and here we are trying to select it. So when it comes to the combination, the order doesn't matter, and the formula is NCR. Okay, both can be found out using the calculator. Now comes the Bernoulli's trial. So Bernoulli's trial, the conditions are they have asked this a couple of times in the exam. So for the Bernoulli's trials, you will have always two outcomes, which will be success or the failure, and that is what we find out when you work with the Bernoulli's. And you will have a limited number of trials, and also the probability of the success and the probability of the failure will remain constant from trial to trial, and you will have a fixed number of trials. If an event satisfy all of these, then you can say it is a Bernoulli's trials. And whenever it is a Bernoulli's trials, you will work with the formula. So P is the probability of the success and Q is the probability of the failure. And the probability of the event, the success event happening is like NCR, P to the power of R, Q to the power of N minus R. Okay. Now there are three cases where we work with the Bernoulli's. That is the first success after N trials. Okay, so here there are three failures, like for example this one, 3 failures and then the first success. S is the success. So if that is the case, then we work with Bernoulli's. And the next one is K success in N trials. Like they are saying that in 5 trials you should have 3 successes. So that case also is a particular case of Bernoulli's. And then it is Kth success on Nth trial, which is like 3rd success on the 5th trial. So here you have first success, second success, again you can have anything else, failure over here, and then the 3rd success. So this is a 3rd success on the 5th trial. So this is also a specific case of Bernoulli's which you need to remember. Now, probability of an event, that is just a formula which is like successful outcomes by total number of outcomes. Now, why I put this here is like when it comes to the combination, usually they ask the probability in combination with the combination. I mean, in conjunction with the combination. So you will have to work with the successful outcomes will be a combination. So you'll have to maybe 3 choose 5 or something like this divided by 3 choose 7. So these kind of questions are quite common in Living Cert. Okay, and then the another case of probability which you have to remember is a z-score, which many people confuse. Z-score formula, you know, x minus mu over sigma. It is there in the formula book. Mu is the mean and sigma is the standard deviation. Now there are 3 cases which you need to remember, or maybe 4 cases. So P z is less than 1.2. This is there in the formula book directly. So the whatever is there in the formula book in the table of z-scores is the less than value. Now, if it is greater than value, you have to subtract it from P z less than 1.3. Okay, this is the first special case. This is the second special case, which is z is less than minus 1.3. Okay, there's a negative value here. Then you will write it as 1 minus P z less than 1.3. Okay, and this you can find out directly from the formula book. Now, again, last one is like you are having a range of values like 1.2 less than z less than 1.3. Then what you will do? You will find the probability of z less than 1.3 minus z less than 1.2. So these 3 cases you have to remember, and if you have this, you will be able to do the questions pretty easy.